Hey, hi. I'm going to go over that problem that I assigned last week on Friday. Hope you like my new look. I'm starting to like it a little more and more. So anyway, I'm going to start it right now. Okay, here's the problem that I assigned last week on Friday. It's the function f prime, and we're supposed to make decisions about f, like what's happening with f. It's similar to any of those problems where you have g is defined as a function of f, and this would be the graph of f. But then you'd have like f of t dt. So g is defined as an integral of f. But this one's got an initial position of 1, 0. So this integral would go from 1 to x, and there's the x for the g of x. And at time equals 1, the position is 0. So we'd add 3. So there we go. There's g defined as a function of f. But that's not this. This is f prime. We're making decisions about f. So notice for a, it asks for the closed interval, -5 to 5. Find all the x values that have relative maximums. So for a, we're going to make this chart, right? We're going to label it f prime. You should always label it when you do. The numbers you put on the f prime line are the zeros, so -3, 1, and 4. And 4. And then we're going to decide the sign of f prime in each of these intervals, and it's positive because it's above the x-axis, negative because it's below, positive it's above, and negative it's below. So we know f increases, then decreases, then increases, then decreases. And then we can find the maximums, of course, are at -3 and 4. So relative maximum, right. So relative, we're going to set f prime equal to 0. X is -3, x is 1, x is 4. And then f has relative maximums. Oh, it's an I, hello. At x equals -3 and x equals 4, because f prime goes from positive to negative. Okay, now let's look at B. B asks, on the open interval from -5 to 5, find where f has a point of inflection. So we're going to look at the second derivative, B, so f double prime. And we are trying to find the zeros of f double prime are where f prime has max and min. So we've got a max here, a min here. The first derivative, or the second derivative is undefined there, undefined here also. Okay, so on the open interval, if we take -3 and -1, at 1 it's undefined, at 2 it's undefined. But the slope of f prime is positive, then negative, then positive, then negative. So it's positive, then negative. From -1, it's positive to 1, positive from 1 to 2, and then negative after 2 to 5. Okay? That means f is concave up, concave down, concave up, and concave down. So there's a sign change. in f double prime at x equals -3, x equals -1, and x equals 2. So there are inflection points at x equals -3, x equals -1, x equals 2. Probably a better way to say that, but this will get the job done. So for C, we are trying to find where f is concave up and has a positive slope. So from our charts, we can see that it's concave up from -5 to -4, and from -1 to 2, kind of like, because it's undefined anyway there, but and it has a positive slope from -5 to -3 and 1 to 4. On the graph, you can see this pretty easily, because wherever f prime is positive, the function's increasing, or negative, it's decreasing. Whenever the slope of f prime is positive, the function f is concave up. So where it's positive and concave up is from -5 to -4, and from 1 to 2. So f prime is positive, and f double prime is positive on the intervals -5 to -4 and 1 to 2. So for D, we are looking for the absolute minimum over the closed interval. So we're including endpoints this time from -5 to 5. And explain your reasoning. So this is where you have to list all the possibilities. That's usually a point on the AP exam. So for D, we're going to state where minimums can occur, right? Minimums can occur when f prime equals 0 or at endpoints. So from our analysis earlier, we know that we've got maximums at -3 and 4. So the minimum, in this case, since it goes down and up, we have a minimum at 1, and also a minimum at x equals -5 because it increases from there, and another minimum at x equals +5 because it decreases to there. Minimums at x equals -5, x equals +1, and x equals +4. We'll do a really quick sketch with the f prime right, and this explains why. So f of -5 is 3 plus the integral from 1 to -5 of f prime of t, we'll go, dt. Let me think about that for a little bit. I could probably have put x's in, but it doesn't matter. So that is 3 plus, well, the area here, well, it's a circle with a radius of 2, right? So the whole circle would be 4 pi. So this is 2 pi. This is a circle with a radius of 1, but it's half of 1, so this is pi over 2, those areas. And that looks good. This area right here, the base is 1, 2, 3, and the height is 2, so this area is 3. This area in there is 1/2, okay? So we can find all of these. Plus 2 pi minus pi over 2. And I changed the signs of these two, plus 2 pi minus pi over 2, because we're going in a negative direction from 1. So this area turns positive and that area turns negative. We know the position at time equals 3, right? I'm sorry, the time equals 1. We know the position. We know the position at time equals 4 because it's the initial position 3 plus this area, so it's 6. The position at time equals 5 is 6 minus 1/2, it's 5.5. The position at time equals -3 is this 3 plus pi over 2. And then the position at time equals -5 is this initial position 3 plus pi over 2 plus 2 pi minus pi over 2. Okay. So 1 is 3, and f of 4 is 6, 5.5. The absolute minimum at x equals 1, f of 1 is 3. And that should do it. I'm going to erase this because I don't need to be more specific than that. That's fine. Oops, let me show you. Sorry. The absolute minimum at x equals 1, f of 1 is 3. Okay, here are the scoring guidelines. Sets f prime equal to 0. I didn't show that work, right? But these are the zeros of f prime. So I probably should have said f prime equals 0. But anyway, the points we definitely got, the x values and the justification. And the justification, remember, changes from positive to negative, right? You have to state that, right? Inflection point, it changes from increasing to decreasing or vice versa. Or you can say f double prime changes signs, one of those. It just has to be a logical justification. Where it's concave up and positive, right? We want to find out where f prime is above the x-axis and also f prime is increasing, and that we did find those. And then identifies x equals 1 as a candidate, right? Considers the endpoints, and look at, they did it in a similar way that I did, right? And find the absolute minimum. They gave the interval when they summed it up, and I didn't. Would not lose points for that, but maybe it's a little more concise when you give the interval. Anyway, there you go.